Okay, I have 5 minutes, 20 slides, so 15 seconds per slide is a lot to cover. I'm Eric at Tenstorrent, Senior Director of Business Development. Today I'm here to talk to you about RISC-V technology, which we are developing. And I swear when I timed this earlier, I had 15 seconds. So, who is Tenstorrent? We are a Toronto-based Series C startup. We've raised $250 million. We're building AI processing technologies. So, microchips targeted at deep learning applications in particular. We are building CPUs as well, based around the RISC-V ISA. Now, CPUs are essential for tasks that aren't easily parallelizable due to control or data management flows, logic-intensive, latency-sensitive tasks. Boy, 15 seconds goes fast. And today I'm going to talk about CPU and AI accelerators, cover the core products that we have today, which is AI accelerators, talk about that briefly, but then talk to the commercial and technical reasons we like RISC-V. So AI accelerators are specialized hardware designed specifically for deep learning applications, optimized down to the very lowest levels to deliver the maximum performance on those types of applications. What is a RISC? What are the current limitations of CPU technology? So CPUs today are not easily extensible. They are proprietary. They can be expensive to license. And for this reason, we like RISC-V. RISC-V is an open source instruction set. That means you can extend it, you can download it and build off of it for free. It allows for greater innovation, and that's something that we really liked out of that design. RISC-V, while relatively new and basic, is open source, meaning that an expert team can extend it, can add new features, new functionality, and that's exactly what we did. We developed a high-performance design that we can scale from very small to very large. We like it because it's modular. It's composed off a small set of instructions that can be with optional extensions. We've actually added additional vector extensions as well to the RISC-V base product as part of the RISC-V consortium. Let's talk about scalability. So thanks to the modular design, we can scale from very small. We have a 2-bit wide decode option up to 8 wide decode. It is very energy efficient because it allows you to eliminate basically all of the redundant legacy bloatware that appears inside standard CPU technology like x86, ARM, MIPS, these types of things. So you only do what you really need to do. That also helps drive down cost efficiency, of course, because you're not or drive up cost efficiency, because you're not spending money on licensing. The development costs are purely human resourcing and purely in the development of the technology itself. So some of the good use cases we're seeing already are embedded edge, IoT, small devices that swim, walk, crawl, fly, but also in the HPC space as well. If we're developing high-performance technology, we want to put that in the data center. Now, AI is a rapidly developing domain, don't need to tell anybody that, but we need technologies that can keep up with the pace of development. Using new technologies like this allow us to keep up that pace of development and deliver low-cost processing technologies that people can adopt very quickly. But there are real challenges at play. Developing software for RISC-V is not easy, and that's one of the things that continues to be a challenge of the adoption and the emergence of RISC-V, but it is coming down the pipe, and the open source community is driving this forward in a big way. Much like Linux started as a small project, RISC-V started as a small open source project, but is being adopted by companies like ours. And while the most significant problem is the software ecosystem, the open source community is driving that forward. Quickly, what's some differences between RISC-V and other technologies? So RISC-V is open source, as I mentioned. ARM, x86, ARM offers some customizations, x86 and MIPS doesn't. And I'm going to skip a couple of things, but if anybody wants to talk to me here at the end of the presentation, I have a booth and we can go into this in more detail. This is a roadmap of the technology we're developing. Left to right, we have the AI accelerators, and in the far right-hand section here, you can see these CPU bars. That's the RISC-V technology that we're implementing right now. And I'll leave this up for 15 seconds. If anybody would like to reach me or have a conversation about RISC-V or AI acceleration, scan my QR code, and you'll get an email straight to me. Thank you all very much. That was very rushed.